The computer is undoubtedly the most wonderful machine ever designed by man.
I've just dialed 13 digits. London to Paris, our embassy. I got the busy signal, the number was engaged. But even when it doesn't work, it's very remarkable, isn't it? The telephone system is an extraordinarily complicated thing. Very few people understand how it works at all. Everybody uses it. We take it as part of our lives. It would have astonished our grandparents, and yet it is a matter of everyday use for all of us. Or take this thing. How many of us have the remotest idea how those pictures get into our houses? And yet there they are, it's part of our life, it's coming back to dominate the lives of many of us, and yet we don't understand it, we're perfectly happy to take it for granted. But these things in here, they're very different indeed. Now these things do worry people. Very few people understand them yet.
Computers, the strange, mysterious monsters of the 20th century. They seem to defy understanding, shut away in a distant world of their own. These aren't like the television or the telephone at all, or are they? Well, in one sense they're not. For one thing, they're a great deal more difficult to use. You can't just switch on a computer without knowing something about it. But otherwise, like television and the telephone, computers are just servants of man, very obedient servants. Their job is handling data and producing information. Data is fed in, they deal with it as instructed, and then produce the results. Still, to most of us, they're very new and strange servants indeed. Few people are at home in the world of computers, and those who are spend a good deal of time explaining its mysteries to those who aren't. This country house, for example, where Disraeli once lived, is now full of people talking, listening, learning about computers, and the jargon of computers too.
Now, the obvious way to simplify your input and output operations is to use a software package.
The peripheral transfers are autonomous. They don't hold up the central processor.
Once a problem has been flowcharted, the coding is usually quite straightforward. But the debugging, of course, can be very time-consuming.
The Orion uses a 48-bit word. All those in this range use a 24-bit word.
But Clang is one for one. With the higher languages, COBOL, Fortran, Algol, and apt, it's all much simpler once the compilers have been written. And dashes. You can send any.
Take just a group of pulses. Group them this way, and just like Morse code, they might signify J, O, H, N. Or they could spell out a string of numbers, say 5, 9, 7. And all these pulses inside the computer are being moved about at 186,000 miles a second.
So that flash, I arranged for it to last a 50th of a second. Now that's a very short time. A motor car can go about a couple of feet down M1, for example. This computer can do something like 500 lengthy multiplication sums or several tens of thousands of ordinary addition sums in that exceedingly short time. Now for the last 7 seconds, the machine has been working out a complicated schedule of parts which are going to be needed to make another computer. One computer helps to make the next. The calculations took 7 seconds. And we're now going to print out the answers on this printer here. It prints exceedingly quickly, but it's going to take quite a long time to print out the answers which the machine calculated in this time of 7 seconds. Now watch. In fact, this printer will have to go on 55 seconds at this speed to to produce all the answers which are worked out by the computer in 7 seconds. This sort of speed of calculation makes a complete nonsense of ordinary methods with which we've been so familiar. And it makes nonsense of this sort of thing too.
Logical, one step at a time. A good way of instructing an old lady. The only way to instruct a computer. So the first stage in programming a computer is to set down all the steps involved, like this, in a flowchart.
And remember, a flowchart must not only be logical, every step. Here's a flowchart for getting up in the morning. Look at it carefully, because there's a deliberate mistake in it. And I want you to try to tell me what's missing. Nobody spotted it? Well, there's no instruction saying get dressed. And it's no use expecting the computer to say to itself, the silly fool forgot to say get dressed, and put it in for itself. Computers can't think. Whoever went to work on the basis of this flowchart would set off in his pajamas. And the results of omitting a vital step from a business procedure can be just as embarrassing.
Precise logical instructions built up step by step. And the writing of these instructions is called programming.
Programming. There are at least 250,000 people in the world already involved in the business of programming computers. In Britain, several thousand more programmers are needed every year. People trained in the art of writing instructions like these. Instructions to computers written in any one of several cryptic computer codes. Instruction to convert flowchart diagrams into a series of equally logical instructions which the machine can understand. Programming ranges from the most abstruse and ingenious to the most simple and painstaking tasks. Take this girl, an attractive girl waiting to cross the road. We can assume that she knows how to cross roads safely.
But imagine she had to be programmed to cross that road, like a computer. In fact, by this program. Now, he can't see the girl, and he can't see the road. All he can do is issue a set of instructions just as he would to a computer. The girl will ignore her own instinct and judgment and obey the program slavishly and exactly, just as a computer would. Take one step forward.
Are you at the edge of the pavement? If no, go back to instruction 1.
No.
Take one step forward. Are you at the edge of the pavement? If yes, go on to next instruction.
Yes.
Stop. Look right.
Is there a vehicle in sight?
Yes.
Is there a vehicle within 12 yards?
Yes.
Is there a vehicle within 12 yards?
If yes, go back to last instruction.
Yes.
Is there a vehicle within 12 yards? If yes, go back to last instruction.
Yes.
Is there a vehicle within 12 yards?
If yes, go back to last instruction.
Yes.
That's what's gone wrong. That's why, with a clear road and no moving car within 12 yards, the girl still isn't crossing. The programmer had forgotten all about parked cars.
Is there a vehicle within 12 yards?
Yes.
Is the vehicle stationary? If yes, go to the next instruction.
Yes.
Is there a vehicle within
30 yards.
No.
Is there a vehicle within
60 yards.
No.
Cross the road.
Simple, monotonous, but a really full list of instructions to move the girl even across a one-way street, would have been far too complicated for any computer. Look at her walking. She controls her muscles automatically. She has a complex nervous system. She understands English. The computer has none of these natural advantages. Our girl knows how to do multiplication. Many computers can't even manage that. They multiply by adding over and over again, an incredibly cumbersome way of doing things. If the computer didn't do 10 million additional